I'm Joe Bonventri. I'm the head of the kidney group of the Harvard Stem Cell Institute and also chief of the renal division at the Brigham and Women's Hospital, as well as chief of the HST Biomedical Engineering Division at the Brigham. Kidney disease affects approximately 8 or 9% of individuals above the age of 40, and that's worldwide. It can be manifest in very silent ways, and ultimately in too many patients leads to end-stage renal disease, which then requires the patient be supported with dialysis or transplantation. So that's a good question. So what we'll know is when you come in for dialysis, your blood tests will be changed a bit each time. With regard to the kidney program, I think some of the most important contributions have been the understanding of developmental lineage, that is, which cells or which genes are present early on which seem to dictate whether cells are going to remain as stem cells or whether they're going to remain as kidney progenitors, or whether they're going to start down a path that will result in them being a proximal tubule cell, a cell of the collecting system, or a cell of the interstitium, or a cell of the glomerulus, let's say, of the filtering unit. The screening capabilities that the Stem Cell Institute has established are very valuable from a number of perspectives. And on the one hand, we can combine them with these genetic rearrangements to be able to try to identify factors that will differentiate cells down a pathway from a stem cell, let's say, to a proximal tubule cell. And in fact, one of the major focuses of the kidney program is what we've called the Proximal Tubule Project. And the goal there is to make as close to possible a proximal tubule in vitro, we call it outside the body. Hi, Albert.
Oh, hi, Dr. Bonventri. How are you?
All right. So how did that laser capture work go?
It went pretty well. It was a preliminary experiment, and I just wanted to show you some of the data that I got from last week. So we're looking here at, I isolated embryonic day 13.5 mouse kidneys.
Dialysis is not ideal from a variety of perspectives. It replaces certain things like filtration, but it doesn't really replace a lot of the functions of the kidney. How long did you know about kidney disease before that? Even if we didn't change dialysis per se in requiring patient to be hooked up to a machine 3 days a week or so, or longer, or more often, we might be able to add a cartridge onto the machinery that could serve as an artificial proximal tubule and could do some of the other things that the kidney does, which is not done by filtering replacement system, which we have now, which is basically our traditional dialysis. As a longer-term goal, we would clearly like to generate new functional units. This is where the fish come in, because the fish can make new functional units, whereas in humans and other mammals, we can only repair functional units. We can't make new ones. And so we're trying to understand how the fish make new functional units. They make them in response to the same drugs that damage nephrons in people, but they have a much more robust response. Not only can they repair the units that are not irreversibly damaged, but they can make new units to replace the ones that are irreversibly damaged. Reprogramming is a situation where you can take a cell that is one type of cell and make another type of cell out of it. So now we can take a patient with a disease like polycystic kidney disease. So we can take cells from those patients and we can make pluripotent cells. we can then try to differentiate those cells to make proximal tubule cells in the kidney, or distal tubule cells, or collecting duct cells in the kidney, different types of cells in the kidney. And since the disease involves cyst formation in these structures, we can then try to use these cells to understand why those cysts form, and we can introduce new therapeutic agents. We can screen for new therapeutic agents that will either arrest the development of those cysts or reverse them. My own feeling is that where we are now, 6 months from a time when this wasn't really on the table, but within 6 months, within the last year, there have been enormous advances. And from all I can tell from everything that's going on in the Harvard Stem Cell Institute, there are enormous advances that are going to come out in the next year.